Howdy. We're ready for getting close to the end here. We've all got the final left. So I've prepared some study reminders. It's not a comprehensive study guide for the final, just some reminders to kind of refresh our memory on some stuff. So we'll start off. Make sure you know the differences between an alkane, an alkene, an alkyne. All right. We want to be able to number these correctly. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Come up with a couple of different names. The easiest way on this one is probably going to be 1, 2, 3, 4, 5. So this would be a 3-ethyl 2,4-dimethyl pentane. All right. We want to know that it's going to be saturated. In other words, it follows the formula CnH2n plus 2. So if I gave you a compound and I said hexane, you could figure out that it was C6H14. Okay. Then we want to make sure that we remember this idea of eclipsed versus staggered. Staggered is what we usually draw in our zigzag. That's what everything wants to adopt. We want to look at, can't erase that. We want to look at alkenes. Make sure that we can name these. Don't forget you've got to include whether it's cis or trans. So this one happens to be trans. So 1, 2, 3, 4, 5. So this would be trans 2-pentene, right? 1, 2, 3, 4, 5. This would be cis 2-pentene. All right. So make sure you're able to remember those. Alkynes, that triple bond. Remember, this has 1, 2, 3, 4 carbons. All right. So this would be butane. All right. So that would be 2-butane, actually. Make sure you remember how to do Markovnikov. His rule is for addition. Specifically, we're applying the H goes to the carbon that has more H's. If we're doing, for instance, something like this, and we're adding water. All right, so the H in our water will go to the carbon that has more H's. So we end up with 3 here and an OH there. Easy enough. Remember Zaitsev. Zaitsev's rule. He said, hey, if you're going to reverse this and you're going to have a choice in double bonds, that the more highly substituted double bond is better than the less highly substituted. And our picture there always was, when we say substituted, we're replacing these H's, and that's the substitution we're looking at. All right. So we want to remember all of those kind of things. We talked about rings and naming those. We need to make sure that we remember how to handle stereochemistry on these rings. In other words, if we put these wedges and dashes, if we can tell some like that a chlorine and this is a chlorine, we could tell if it was cis or trans. So if they're on the same side, it's cis. This particular one is trans. All right. So we could number it 1, 2, and work our way around. So I could make this 1, 2, 3, 4, 5. The key was one of them had to be 1, one had to be 2. And so trans 1, 2, dichloryl, cyclo, get the cyclo, pentane. All right. Easy enough. We had a discussion about aliphatic versus aromatic. A primary aromatic being benzene ring. All right. Aliphatic just means not aromatic. Aromatic things unexpectedly stable. They are so stable that we will do substitution, never addition. All right. So we're looking for our benzene ring pattern. We don't want to break that pattern. Okay. Um, let's see. I've got this drawn up a little bit. We looked at if I put a methyl group here and I drew in another methyl group, we should be able to tell what the substitution pattern is here. And so this one is meta. Don't forget, here's ortho relationship. And then this one would be a para relationship. All right, so ortho, meta, para, make sure you're able to remember those. Let's see. We had lots of classes of compounds, so we'll definitely have discussions on as we start to get into stuff like that's an aldehyde. Be prepared to name it. For the ones less than 5, be able to do the common names for our F, A, P, B, V. 1, 2, 3, 4, 5. All right. So this one, 1, 2, 3, 4, be butanal with an AL or butyraldehyde. That's always a fun one to say. The alcohol, make sure you're able to tell that this is a secondary alcohol, that it would go on to a ketone if we oxidized it. All right. Be able to name it. So 1, 2, 3, 4, 5, 2-pentanol. All right. Make sure you remember this side group. This is an isopropyl group. We use that a lot. Let's see other things. Carboxylic acid, be able to name 1 through 5, be able to tell me that's butyric acid. 2, 3, 4. You could also do butanoic acid. Make sure you're able to recognize and name a ketone, 2-butanone. All right. We had a lot of acid derivatives. 1, 2, 3. This would be propanamine. And then we can, propanamide. And then we also had amines. So amides and amines, make sure you tell those apart. Be careful on the amines. They're different than the alcohol. And so the alcohol, we based it off of this carbon, and it was a secondary carbon, so that's a secondary alcohol. Amines are based off of the nitrogens. And so even though this is a secondary carbon, this is a primary amine. So be careful about things like that. This is a primary aldehyde, not primary amide. Sorry. Just looking down next, aldehyde. We got ketones, amines, primary, secondary, tertiary, esters. versus ethers. Make sure you can name those. Remember that amines and amides are bases. Carboxylic acids are acids. I'll be asking about that kind of relationship. Um, let's see, carboxylic acids, we get long chains of those. Then we get a fatty acid. We replace that with long chain carbon, get a wax. Okay. The process of making those and breaking them apart, we need to know those. Fatty acids, when I go back to my fatty acids, remember their saturation, saturated versus unsaturated, is different. It doesn't include the carbonyl. All right. So then if I were to make this unsaturated, you want to remember that it's going to be cis in nature. And this one is, if I can make an omega, there you go. This would be an omega 3 unsaturated fatty acid. All right. Let's see what else we got. Waxes. We want to make sure we know, we can recognize triglycerides. We're looking for that basic structure. We can add on to it. So we're going to add on to this by esterification. We break it apart, usually with the base catalyzed. So that's saponification. We used it a lot. Let's see, we had, what other reactions we want to make sure we know. Make sure you know reductants. We use that all semester, platinum, palladium, or nickel with hydrogen gas. Combustion reactions, recognize those. Saponification, reductions, esterification. Okay. Let's see what other structures we want to know. So steroids, pretty easy. Make sure you remember their kind of iconic here. 5 rings, or 4 rings, sorry. So 1, 2, 3, 4 rings in that shape. So that's a steroid. Make sure you're able to do all kinds of stuff with sugars. Let's draw this one. First thing you need to know is it Fischer projection, the Hawthorne projection. So this one's Hawthorne. All right. We need to be able to tell all kinds of stuff right here. So looking here, I can tell, because this is an H, that this was an aldehyde. This structure, this, can't make it prettier. There we go. Carbon that has an ether group on it and an OH. It's a hemiacetal. We can also tell this is on the bottom. The CH2OH is on the top. They're opposite each other. That's alpha. Okay. 1, 2, 3, 4, 5. This is a pentose, so it's an aldopentose in the alpha configuration. So we could look at something like this. In the Fischer projection, be able to tell this is a ketone. 1, 2, 3, 4, 5. So it's a ketopentose. You need to be able to look down here. Tell that one's in the L configuration. That's got two chiral center. It's got if I were to draw this, I'd have an enantiomer. So make sure you know enantiomer, diastereomer. Enantiomer, they're mirror images. Diastereomer, that includes cis and trans as well, but they're not mirror images. These happen to be mirror images. These would be enantiomers. Diastereomers, non-superimposable, but they're not mirror images. And then you have this idea of meso, and meso is when we can draw a line. And the giveaway for it, you got to always kind of check for meso. We'll be asking about it, and it'll have the top and the bottom be the same. All right, and you don't see that in the sugars. But you do see it in some similar drawings. So always watch out for meso. We like to hit you with that. Let's see. So we talked about hemiacetal. So in lab we used this kind of idea for this compound. So this would be this carbon here has two ether groups, two oxygens connected to carbons on it. So it's an acetal. We could use that as protecting groups. So I'll be able to tell the difference between those. Let's see, what else do we want to know? We did a lot of stuff with amino acids. And they, for the most part, had this kind of drawing. That should be a plus. Whatever R is. And the H comes off. Typically we draw it up here, but it didn't come off to the bottom. Whatever. All right. Remember these were Zwitter ions. Okay. We look up the R. I'll give you the amino acid list, but you'll need to assign what the R is. When we put these together and start to make proteins out of them, you're looking for this pattern NCC, right? R is always off that middle C. That's where the R is that you're looking for. It'll have the H usually up here. All right. Let's see. D versus L on these as well. If we do them in Fischer. So in nature, here's our things that we need to memorize about in nature. Nature, all right. Sugars are going to be D. Amino acids will be L. And fatty acids that are unsaturated will be cis. And so those are three trends we want to make sure we memorize. Else I'm missing. Trends. Be able to do. So look at those last few homeworks in that last test. So we'll have several of this where I have the NCC, ask how many there are, to tell me what they are. So you'll have to look up the R's. All right. So go back, review the naming, just go through the homework, the best bet on these. All right. Go through the homework. You can go through those tests, but it's not so bad. All right. Just practice it. If you can do the homeworks, you can do this final. So we'll catch you on the next one.